Next, I believe this item will attract significant user interest, creating a structural analysis model from 2D drawings. What if we could automatically generate a structural analysis model directly from 2D drawings you have? This is the future that Midas IT aim to create. So if we have these 2D drawings, I think we can create this structural model in CivilNX side. So there are drawings of bridge substructure, including top view and elevation view and section view. The layers are aligned to match the same elements. So in my understanding, we always have this kind of drawing, and with this drawing, we start to create modeling. So now we can bring this drawing into the Grasshopper like this. Then we generate a 3D model for each element from this drawing. You know, it is possible because it is definitely possible because we have all the information for the modeling. So as you can see here, we can create bearing and pier cap, pier, and foundation as well. And after that, we can send this model into CivilNX. Yeah, like this. So in this way, we can easily create modeling from 2D drawings. From 2D drawings, you can bring it into the Grasshopper and you can create the modeling from Grasshopper, and then you can send it to the CivilNX. All right, instead of creating a single pier, you can place piers at the desired locations along the bridge alignment. So the pier position can be adjusted based on the bridge alignment and ground conditions. First, implement this in Grasshopper side and then transfer it to CivilNX. Today, I will show you a construction stage template and how to set up the construction stages using GH plugin. So I will focus on free cantilever method, which is one of the most commonly used method in construction field. To define the construction stages, we first need to divide the models into different groups. So the model is divided into sections such as pier, table, and segment and pier to properly set up the construction sequence. You can set the variables you need and easily adjust them. For example, you can define the start and end point of the bridges and pier location and segment spacing and pier height. These parameters can be modified to fit exactly you want in the future. First, we create nodes and elements to define the geometry, followed by the sections and material properties. So we can create the nodes and elements and considering the sections as well. And the most important step is assigning groups to activate or deactivate elements, loads, and boundary conditions at specific stages. So as you can see here, we are creating the groups. And after that, like boundary groups need to be created for abutment, pier bases, and bearings. Next, we need to apply loads and define load groups. And the number of construction stages is automatically determined based on the number of segments and the necessary construction steps. Each construction stage duration is set by connecting the work time and additional data in sequence. And for load group, both activation and deactivation are considered. And as you can see here, the construction stage is now defined. By selecting Define CS, you can see the predefined construction stages in the element and boundary and load sections. You can check which groups are activated or deactivated, as well as the duration of each stages. And this kind of table also records these activations and deactivations. So to ensure the correct application of bridge alignment changes, modifications to the bridge alignment and segment lengths be made. This will automatically update the number of construction stages. So once updated, the model can be applied in CivilNX. So you can change the segment length from here. And the revised construction stages can be reviewed along with the updated construction stage tables.